Hello, future doctors, and welcome to our IMAT preparation series. And today we're going to build a rock-solid foundation for the entire mathematics section. The topic is number systems: natural, integers, rational, and irrational numbers. Now, you might think this is basic, but the IMAT loves to test your understanding of the properties and relationships between these numbers in its logic and math sections. Mastering these fundamentals is not just about calculation. It's about clear, logical thinking. So let's begin. Part 1. The origin natural numbers. Imagine you are a prehistoric human. What's the first mathematical concept you need? Counting. How many sheep do I have? How many apples did I gather? The numbers you use for counting are called natural numbers. Definition. These are the positive counting numbers starting from 1 and equals 1, 2, 3, 4, and so on. The symbol for the set of natural numbers is script n. IMAT tip-off. Some conventions, especially in computer science, include 0 in the set of natural numbers. For IMAT and standard mathematics, assume script n starts from 1 unless the question specifies otherwise. Properties. 2 natural numbers, you get another natural number. For example, 3 plus 5 equals 8. If you multiply 2 natural numbers, you get another natural number. For example, 3 times 5 equals 15. The problem: what happens if you try to subtract a larger number from a smaller one? For example, what is 3 minus 5? The answer is not a natural number. This limitation leads us to our next set. Part 2. Introducing balance. Integers. To solve the problem of subtraction, we need to introduce 0 and negative numbers. This expanded set is called the integers. Definition. Integers include all natural numbers, their negative counterparts, and 0. Z equals minus 3, minus 2, minus 1, 0, 1, 2, 3, and so on. The symbol is script Z, from the German word Zahlen, which means numbers relationship. Notice that every natural number is also an integer. We can say that script n is a subset of script Z. This concept of nested sets is critical for IMAT. N is a subset of script Z. Key properties. Integers are closed under addition, subtraction, and multiplication. This means if you add, subtract, or multiply any 2 integers, the result will always be another integer. What happens when you divide 2 integers? What is 10 divided by 4? The answer is 2.5, which is not an integer. This leads us to the next, much larger set. Part 3. Filling the gaps, rational numbers. Rational numbers solve the problem of division. The name itself gives you a clue: ratio. A rational number is any number that can be expressed as a fraction or ratio p over q, where p and q are integers, and crucially, q is not equal to 0, because division by 0 is undefined. The symbol is script q from the word quotient. 1/2 negative 7/3. 5, because that's 5 over 1, negative 0.25, because that's negative 1 over 4. Every integer is a rational number, since any integer z can be written as z over 1. So our nested sets now look like this. N is a subset of script Z is a subset of script Q. The most important property for IMAT. Decimal representation. IMAT questions will often test you on how to identify a rational number from its decimal form. A number is rational if its decimal representation does one of 2 things: terminates, that is, stops. For example, 1/8 equals 0.125. It ends, that is, repeats in a pattern. For example, 1/3 equals 0.333. The 3 repeats forever. Or 1/7 equals 0.142857. 142857. The block 142857 repeats forever. If you see a decimal that stops or repeats, it must be a rational number. Part 4. The others, irrational numbers. So, are there any numbers left on the number line? Yes. These are the irrational numbers. An irrational number is a number that cannot be expressed as a simple fraction p over q. Their decimal form never terminates and never repeats. It goes on forever in a completely random-seeming pattern. IMAT examples. Memorize these: asterisk pi, approximately 3.14159, goes on forever with no pattern. E, Euler's number, approximately 2.71828, goes on forever, no pattern. Square roots of non-perfect squares. Square root of 2, square root of 3, square root of 5, and so on. These are the most common irrational numbers you will see on the test. Note, square root of 4 is not irrational because square root of 4 is 2, which is an integer. Crucial point. A number is either rational or irrational. It cannot be both. They are two completely separate categories of numbers. Part 5, the complete picture, real numbers. When we take all the rational numbers and all the irrational numbers and put them together, we get the set of real numbers. The set of all numbers that can be placed on the number line. Script are: real numbers consist of the union of the rational script Q and irrational script I number sets. Here is a visual summary. Real numbers, rational and irrational. Rationals, integers and fractions. Integers, negatives, 0, and natural numbers. Question 2. Let x be an irrational number and y be a non-zero rational number. Which of the following statements is always true? A. X plus y is rational. B. X times y is rational. C. X squared is rational. D. X plus y is irrational. E. X divided by y is rational. Solution. Let's use square root of 2 as our test irrational number for x, and 3 as our test rational number for y. X plus y equals square root of 2 plus 3. This is still irrational. Asterisk B. X times y equals 3 times square root of 2. This is still irrational. C. X squared equals the square of square root of 2. That's 2, which is rational, but if x is cube root of 2, x squared is not rational. So this is not always true. D. The sum or difference of an irrational number and a rational number is always irrational. This is always true. E. X divided by y, such as square root of 2 over 3, is still irrational. The correct answer is D. Question 3. Which of the following statements is correct? A. Every rational number is an integer. B. The set of natural numbers includes 0. C. Every integer is a real number. D. An irrational number can be written as a fraction. E. The product of two irrational numbers is always irrational. Solution. Asterisk A. False. 1/2 is rational but not an integer. B. False. By standard convention, natural numbers start from 1. C. True. The set of real numbers contains all rational numbers including integers and all irrational numbers. D. False. Rational numbers can be written as fractions, not irrationals. E. False. For example, square root of 2 times square root of 2 is 2, which is rational. The correct answer is C. So, to summarize for your IMAT revision, category symbol definition decimal form. Natural script n counting numbers 1, 2, 3. Integer script z whole numbers and negatives -1, 0, 1, and so on. Rational script q fraction p over q terminates or repeats. Irrational script I cannot be written as a fraction, never terminates, never repeats. Real script are all numbers on the number line, all possible decimals. Remember the hierarchy. Script n is a subset of script z, which is a subset of script q, which is a subset of script r. Understand key decimal properties and memorize the classic examples of irrational numbers. That's all for today. Practice these concepts, and you'll be one step closer to acing that IMAT. Keep up the hard work, and I'll see you in the next lecture.